And
so then this is basically saying that all FS log structures, they really look like the strict normal crossings divisor thing, but then after.
No. So I mean,
this is a particularly nice situation,
so
I think.
An FS chart is giving such a chart is somehow modeling your log structure locally on the log structure you see on spec of ZP.
Yes.
Okay.
And that's
Spec of ZP is a toric scheme, so it has a toric boundary divisor, and you this gives you some log structure, and you locally model the log structure on this toric thing. So it's not quite strict normal crossing; it's something quite a bit weaker. But it's.
But I think it will be clear when we see log smoothness.
So finitely generated.
Is this P2CP node? Is this
not
toric thing?
No, this could be a singular toric.
Okay.
You could do some monode of Z squared generated by some one.
Strict normal crossings is if P would be say n2.
Okay.
So But you have much more freedom to choose your. But you're not very far from this more. It's also not quite the same.
So maybe I should actually first give this example that when P is a FS monoid, actually satisfying that the units, it has non-trivial units, then this affine variety is actually a toric variety. So such thing as a canonical log structure, so we see that toric varieties have a canonical log structure.
Why do you exclude units? Why? I mean, is not GM also a toric variety?
Yeah, it's true actually.
That is not.
It's not a variety.
I think.
GM of it includes every variety.
Yeah.
I mean, it's not over a field, but you could replace that with a field. You had a comment for a second?
When the torus action is part of the structure, yes.
No, I mean actually I think this is not a toric variety because you need that P group has to be torsion free.
Yeah.
And just an FS monoid does not imply that the groupification is torsion free. Because then when it's torsion free, then it becomes the character group of an algebraic torus, and this is how you get the toric structure. But the condition Fs implies only that P bar group is torsion free. So that's why I was putting the unit, so we know that the groupification is torsion free if it has no units and is Fs. But I think, yeah.
I think it's more about origin than about.
Yeah.
Difference between P bar and P taking the normalization of the variety of the scheme.
That's like the saturation.
Yeah.
Yes.
Something
Deeper.
deeper.
Because it's saturated will mean that they should always be normal, I think.
Okay.
Yeah. So the P bar is like you just throw away the all invertible functions in a sense in P. So okay, so I have very little time and can basically only more or less give the definition. So log regularity is a version of regularity for log schemes, and XM is a log scheme. Then we define for every point of X, we define this ideal of the local ring. Is the ideal generated by, so now here I write mx minus the units. So here this is a minus, and from the map given by the log structure, then Ix is the ideal generated by the image of this under this map. Now X is log regular at X if, first of all, we want that the quotient of the local ring by this ideal is regular in the classical sense, so it's a regular local ring. And secondly, we require that the dimension, here actually X material, or at least locally material. The dimension of this local ring is the dimension of this quotient plus the rank of M bar X groupification. So again, this is a free abelian group, and we take the rank. So somehow we see that the log structure should correct the defect of our original ring. And yeah, so I just do a final remark.
Did you apply actually fs in this definition?
Yes, yes,
Okay.
sorry. Yeah, yeah, yeah.
That's fine. Okay.
FS log scheme. And so if xn is log regular, so we say it's log regular if it's log regular at every point. Then the underlying scheme X is Cohen-Macaulay and normal. So the proof of the first property is reduced to check that these things are Cohen-Macaulay, where P is an FS monoid and R is a nice ring. So I won't say anything with that. But to see, so assume that we know that it is Cohen-Macaulay, and then we can easily prove normal, because if X it is normal, if and only if it's normal in the dimension 1. So we take a point where this has dimension 1, and writing from there, well, we get that in the end the rank of n bar group X is actually smaller or equal than 1. If X is a codimension 1 point. So M bar group can be either Z or 1. So if it's 1, then this ideal is trivial, and
then OXX is regular.
yeah, and then X is regular at and then sorry, I was looking for this. And then X is regular. And if M bar group X is isomorphic to Z, then one can check that this forces our N to be actually isomorphic to N. And yes, but then if N is isomorphic to N, then here we have 1 for this, and then this forces this to be 0. So the ideal equal the maximal ideal in my local ring, and is generated by the image of N. So this says that it's a principal ideal, and so x is a DVR. So regular, and therefore our x is normal. And then I had some other page, but I will stop here, I think.
Are there any more questions or comments?
Can you give an example of something that's log regular?
Yes, so toric varieties are log regular, and this motivating example, I should have said that, that's a log regular. So when we have X regular scheme and the normal crossing divisor in it, that's also log regular.
Somehow that's not very surprising because it's already regular in classicals. I mean,
I-
so the point is that
Yeah, but it's also because it's a toric variety.
yeah, so toric varieties, even if they're singular, they're log regular.
Yes,
So you should think about these two conditions. So you have two conditions
For
here.
example-
First on regularity of this quotient of this local ring. So in a toric variety, you should think about the first condition as saying that the orbits are smooth somehow, or
Yeah.
yeah. And the second condition tells you that if you look at a point, then the dimension of the orbits and the dimension of the stabilizer add up to the ambient dimension. So and a log regular scheme is one which morally has mild singularities and exactly the type of singularities you can find on the toric scheme or a toric variety.
But in the strict normal crossings divisor case, how do I look at the first condition? How do I see that this holds?
It's just
It's just saying that
Yeah.
the intersection of
visualize
the components are
components
smooth.
is
Because
smooth at
Oh,
because
yeah.
the
It's
image-
not,
yeah,
Yeah.
if you think of the chart, the image is exactly
Yeah.
the idea of defining your.
And the second condition tells you that
the co-dimension is empty.
yes, codimension is what you want from
Yeah.
there's no excess. Yeah.
Then actually these log regular schemes also have nice stratification similar to the
Yes.
toric stratification.
Yeah, the orbit
So-
stratification.
Yeah, so I did not have time to say that, but can construct also a fan to a log associated to a log regular scheme, which is a more elaborate version, but essentially equivalent to a fan for toric varieties. And then, and this is also what David mentioned, these toric blow-ups. You
Yeah.
perform operations on the fan and translate them to build out scheme. So I think, yeah, the statement is that every log regular scheme can be, the underlying scheme can be desingularized via these toric blow-ups.
Any other questions or comments? If not, then we can start again in about 8 minutes. As always, volunteers. Oh, next time.